Page A15, Appendix B. All right, Appendix B is where we find all of our statistics. So you'll notice that there's an Appendix B.1 and there's an Appendix B.2 that we're going to be looking at for our statistics. They tell me there on page A15 that statistics is the branch of mathematics that studies techniques for collecting, organizing, and interpreting data. In this section, you're going to look at several ways that you can organize copious amounts of information. So, like example number 1, it says use a line plot to organize the following test scores, and they go through and they give me like 30 different test scores. When I'm just looking at a list of numbers, it doesn't do me any good at all. Like, I can't tell, did they do well, did they not do well, what was kind of the average score, what was the most common type of score, but I can tell that a whole lot better if I arrange it into some type of a graphical form or a pictorial form. And that's what statistics helps me do. It helps me organize that information. So when we're looking at a line plot, which is what they asked me to do in example 1, I need to look at that list of information and find the lowest number and the highest number. So when I go through and look, the lowest number I see is in that first row, 64, and the highest number I see is in the second row, 96. So that means that I'm going to need to draw a number line that goes from 64 to 96. So I just started mine at 60 and went to 100. Now, I can't really like count by 2s or 5s or anything like that here, because I'm going to need to be able to indicate every single unit. So I literally do have to go through and draw each of those out. So when I go to plot the information in that list of scores, the first one was 93. So literally I'm just going to go right above 93 and put an X. And then the next one was 70, so I'll go over to 70 and put an X. And then the next one was 76, so I'll go there and put an X. So it's not difficult at all, it's just kind of tedious to go through and put all 30 entries on there. Occasionally, I'm going to come to the same answer more than once, and so when that happens, I'm just going to start stacking my X's. So like the next time I see a 76, since there's already an X on top of 76, then I just start stacking them up. So if we went through and we put all of those test scores there from example number 1 onto our line plot, it would look like this. Now I have a better understanding of this information because I can see, the majority of the grades were kind of in here. I also would be able to see, like they asked me for this, what number score occurs with the greatest frequency. I'm just looking for the tallest tower of X's, right? So what would my most frequently occurring score be? What was my tallest tower of X's? Yeah, the 76. All right, the second way that they tell me that I could organize this same list of information is with a histogram. Well, let's look at a stem and leaf plot first, and then we'll look at a histogram. For a stem and leaf plot, we're going to go through and we're going to put the tens digit in the stem column, and we're going to put the ones digit in the leaf column. So we're going to take those same entries. They took the exact same list of numbers, but they did change one of them. I'm not sure if that was intentional or accidental, but they give us the exact same list of numbers on the bottom right-hand side of page A15. And if you'll notice, the fourth score there is 58. It was 67 in the original list. It's 58 here. So I don't know whether they intended to do that or not, but we are going to have one number different than the list that we had just a second ago. So again, when I go, before I didn't have an entry over here at 58 to worry about, but I am going to need a 5 in my stems to catch that one. But otherwise, the highest number, remember, was 96, so I know that my numbers are going to need to go up to 9 here. Now, when I put my leaves on, they tell me that they want me to put my leaves in order. So 2 options. You can go through and you can take all of these numbers and put them in order from largest to smallest or smallest to largest first before you start. Or when you put your leaves on, you can just kind of space them out a little bit. What I mean by that is like the first one that they gave me there was 93. So I've got my 9 for my stem. I'm going to come over here and put my 3 for my leaf. And then the next one that I had was 70. So same idea, I've got my 7 for my stem. I'll come over here and put my 0 for my leaf. Then when I have 76, instead of putting my 6 right here beside it, I'm going to leave some space because I know there are going to be some other values in there. So I'm going to move that 6 over and just leave some room for my other leaves. So if you want to go through and put them all in order first, you can, and you won't have to worry about that. Otherwise, just space them out a little bit. So if we went through and we filled in the rest of those values, then this is the stem and leaf plot that we would end up with. Now, a couple of things about these. You could turn your stem and leaf plot sideways, and you're basically looking at a bar graph, right? So that gives me a really clear indicator, again, of an organization of this data that, you know, the majority of the students were scoring in here. Again, it would be easy to see the most frequently occurring score and where the bulk of the scores are. We also can use a stem and leaf plot to compare two different sets of information. We call it a double stem and leaf plot. And that's what they give us over on page A16 in example number 2. Example 2 says, use a stem and leaf plot to compare the test scores given on page A15 with the following test scores to see which set of test scores is better. So we can take the second set of test scores that they give us, and we can put it over here on the opposite side of our stem. So what that would look like is I can list a second set of leaves over here. Now I'm going to do it the same way. I'm going to have the lowest number nearest the stem, and then they're going to get larger as they go out. So if I put that second set of scores on there, then that's what my double stem and leaf plot would look like. The nice thing about that is it's pretty easy to compare large amounts of data that way, because I can look at it and see, okay, this class, the majority of their scores were kind of in the 60s, 70s, and 80s. This class, the majority of their scores were down here in the 70s, 80s, and 90s. So I can see, yeah, those scores were better in the second set of information than the first set. So I can turn my stem and leaf plot sideways for a bar graph. I can make a double stem and leaf plot to compare two things, and I always want to be sure that I put my leaves in order. All right. Then on the bottom of A16, they give us another example of a stem and leaf plot. We've already done a couple, but I just wanted to point out to you about that one. For that one, they had decimals. So you can alter your stems and your leaves as you need to represent your information. Like for the decimals, they put the whole number in the stem, and then they put the decimal in the leaf. If you had a list of 3-digit numbers, like maybe you were working with things in between 100 and 195, something like that, what you could do is you could put the first 2 digits in your stem. So you could do like 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and then you would still just be putting that last digit in your leaf. So you can adjust your stem and leaf plot for the information that you're given. All right, then on A17, they talk to us about histograms and frequency distributions. Now, histograms are very similar to bar graphs. They're not exactly the same. In the middle of A17, it says a histogram has a portion of a real number line as its horizontal axis. A histogram is similar to a bar graph, except that the rectangles or bars in a bar graph can be either horizontal or vertical. And the labels on the bars don't necessarily have to be numbers, so you could represent something totally different with them. Another difference between a bar graph and a histogram is that the bars in a bar graph are usually separated by spaces, whereas the bars in a histogram are not. So example number 4, it says a company has 48 sales representatives who sold the following number of units during the first quarter of 2000. Construct a grouped frequency distribution for this data, and then we could use that to make a histogram. Grouped frequency distribution is a fancy name for a tally chart. So if I look at all that information, in the 5th column, you're going to see your highest number and your lowest number. Because remember, like when we did our line plot up here, we had to know like what was the highest value that we were going to use and what was the lowest value we were going to use, so we knew how long to make that number line. Same thing with our stem and leaf plot. We had to know the high and the low values, so we knew what to use for our stems. So that's the first thing that I want to identify, my high and my low. And they're both in that fifth column. 100 is my low and 195 is my high. This is not there in the textbook, but it does show up on the homework. They'll ask you for the range of your scores, and your range is just your high value minus your low value. That's all that it is. So in this case, we've got a range of 95. So I can go through then, if I have a range of 95, and decide how large I want my intervals to be. Like if I counted by fives, I'd end up having to draw like 20 bars for my bar graph or for my histogram. So I think I'm going to go by tens instead, and that way I would have like 10 for my histogram. I probably don't want to go much bigger than that. Like I don't want to get so large that I only have like 3 or 4 bars on my graph, or I'm going to lose the specificity of my graph. So if we go through and we count by tens, then we could go through and say, okay, this first one's going to go from 100 to 109, and the next one's going to go from 110 to 119. So even though you're breaking this up, okay, 100, 110, 120, 130, 140, you have to differentiate somewhere, because if you have a score of 110, it's not going to go in the first interval and the second interval. So I'm going to stop that first interval at 109 and pick up the next one with 110, and then 119, 120 to 129, 130 to 139, and so on. So when I see that list of numbers, I start with 107, and 107 would be in the interval from 100 to 109, so I can just put a little tick mark there. And then the next one was 105, so in that same interval. And then the next one was 150. So I'll come down here to the interval for 150 to 159, and we'll just keep going with that same process and just create, in essence, a tally chart. That is my grouped frequency distribution. One thing I would mention to you is that even though the largest value was 195, notice that our last interval down here doesn't go 190 to 195. I need to keep those intervals equal. So if all of them were going from, 180 to 189, I need this one to go 190 to 199, not make it shorter. All right, so once I have my frequency distribution, then that will tell me how I can construct my histogram. Because I can come over here and say, okay, for the first interval, 100 to 109, there were 8. So I'm going to have that bar go up to 8. And then the next interval had 1. And then 3, and then 3, and then 7, and then 5, and then 8, and then 6, and then 2, and then 5. So I know that you have been doing these since 3rd grade, and they're very easy. So here's what we want to watch out for, because we don't want to lose points on silly things on the test. So here's a couple of things. Be sure that you don't put a space between the bars, because that was something they just told me that was true with histograms. Also, you need to indicate if you're going to use a scale other than 1. Over here, I didn't have to say what my scale was because I'm counting by ones. So if I don't put a scale, they'll assume it's ones. But down here, remember, we weren't counting by ones, and so I need to indicate my scale. Also, I need a title and I need labels on each of my axes. The whole purpose of graphing this is for somebody to be able to look at it and get the whole picture and understand what's going on, and not have to go read the paragraph out of the book to understand it, or go read the report that explains it. So I definitely want to be sure that I'm giving them the title of what they're looking at, and that I'm labeling each of my axes so that they know what these numbers represent. Also, this value is literally my origin. Remember that they said the horizontal axis is like a portion of a number line. So this literally is like my origin, 0, 0. So we went 0, 1, 2, 3, 4. But down here, the way this starts, it goes 0, 100. It makes it look like we're counting by hundreds, and we're not. This doesn't go 0, 100, 200, that type of thing. So what will enable me to be able to skip values is if I put in this little symbol. I'm sure it has a formal official name. I'm going to call it a squiggle. We're going to put a little squiggle in there to show that I'm skipping from 0 to 100, and then I can start going through with my intervals of 10. So that's what gives me the right to skip over those values. If I don't have that in there, then I would have to go through and say, okay, 0 to 9, 10 to 19, 20 to 29, 30 to 30. I'd have to fill all of those in if I didn't put that symbol in there. Also, you'll notice that we put our intervals on the horizontal axis, and we put our frequency on the vertical axis, because that frequency is going to depend on the interval. So we typically put the dependent on Y or on the vertical, and we put the independent on X or on the horizontal. Okay, so just some things we want to be careful of so that we don't lose silly points when it comes to the test. All right, we do not need to do a ton of these tonight. They're not hard, but they are time consuming. So just a couple of these. On page A20, we're going to do 1, 3, 5, 6, and 9. Challenge is number 7. Now, the answers for these are in the back of the book, like the rest of your answers are. They're on page A178 if you're looking for them.